So far, we've talked about sodium, potassium, and calcium, the channels a cell uses to fire. Today, a wholly different class. They aren't built to fire. They're the body's sensors, detecting heat, spice, and pain from the outside world. Let's start with the fire of biting into a chilly TRPV1. First, what it is. TRPV1 is a non-selective cation channel, sitting on the endings of pain nerves, an all-in-one alarm. It's opened by three things at once: high temperature, above about 43 degrees, acid, and capsaicin, the compound in chili. So that burning feeling when you eat something spicy isn't a real burn. Capsaicin has tricked open a channel meant to report heat, and the brain receives exactly the same hot signal. The fascinating part: stimulate it long enough and it relieves pain. Capsaicin first makes TRPV1 fire wildly, a fierce burning, but applied at high concentration for long enough, the nerve endings are overloaded with calcium into desensitization, even a temporary retraction and inactivation. The pain fibers are stunned. That's why a high-concentration capsaicin patch treats nerve pain, not anesthesia, but holding down the mute button on the alarm itself. So why not just make a drug to block TRPV1? It sounds perfect, and it runs straight into a trap. Because TRPV1 doesn't only handle pain, it's part of the body's thermostat. Block it with an early antagonist and patients spiked fevers across the board. Worse, with the alarm off, some couldn't feel being scalded. Relieve pain, but don't blindly block, that's the hard part. So what actually reached patients is finesse over brute blocking. The high-concentration capsaicin patch, brand name Q10ZA, works by desensitization rather than block, and is approved for post-shingles nerve pain. Its sibling TRPV1, the channel opened by the sharp bite of wasabi and mustard, carries high hopes in chronic cough, itch, and inflammatory pain. On the road to non-opioid analgesia, the TRP family is an unavoidable stop, and testing a TRP drug is very different from sodium or potassium channels. TRPV1 is a non-selective cation channel, letting calcium in, especially so screening often watches a calcium flux signal. Add capsaicin, heat, acid, and see how hard calcium pours in. Patch clamp measures how far it opens and how hard an antagonist shuts it. And you keep one eye on the body temperature red line. Whoever can reliably measure both TRPV1's opening and its desensitization holds a key to non-opioid analgesia. Recap: TRPV1 is a non-selective cation channel sensing high heat, acid, and capsaicin, seated on pain nerves. Capsaicin can both ignite it and relieve pain by desensitization. Blocking it hard invites fever and a scald blind spot, while the finesse is the desensitizing patch and its sibling TRPV1. Next time, a younger, more disruptive channel, it senses not heat or spice but touch, and won the 2021 Nobel Prize, Piezo. Follow Channel Observatory, one channel at a time.